Welcome to Study Loop.
In this problem, we're given that 1 liter of sulfuric acid solution contains 571.6 grams, and also the density of the solution in grams per centimeters cubed. Now, given this information, our task is to calculate different types of concentrations: the mass percent, the mole fraction, the molality, and the molarity. So starting with mass percent, recall that the equation for mass percent is mass of solute divided by the total mass times 100%. So we already know the mass of the solute, that's the 571 grams. What we need is the total mass of the solution. And so here's what we know. We know that 1 liter of solution is 1,000 milliliters. So we also know that there's 1.329 grams in 1 milliliter of the solution, because that's the density, and centimeters cubed are equal to milliliters. And so if we know that, then we know that if I had 1,000 milliliters, I should have 1,329 grams in those 1,000 milliliters. Okay. So given that information, we know that 1 liter of solution contains two things. 1 liter solution contains the 571.6 grams. And we know that the total mass of that solution using the density is 1,329 grams. So this is for 1 liter of solution. And that was basically in our givens. We're going to multiply that times 100%. Notice that we've got our solute and the total solution. And what we find is that this is equal to 43.01% hydrochloric acid. Sulfuric acid. Okay. Moving on, we're next asked to find the mole fraction. The mole fraction is equal to the moles of solute divided by the total number of moles. And so here we're going to start with the fact that we're going to again assume that we have 1 liter of solution. And if we have 1 liter of solution, we have 571.6 grams of H2SO4. We can divide by the molar mass, which is 98.08 grams for every 1 mole of H2SO4, and find that total that is 5.827 moles of H2SO4, which is our solute. We're going to set that aside. So we have 5.827 moles of H2SO4. That's the moles of solute up there. Next, we need to find the total moles. And so the total moles is going to be moles of H2SO4 plus moles of water. How are we going to find that? Well, we know already from our work up here that if I have 1 liter, I'm going to have a total of 1,329 grams. So if I have 1,329 grams of solution, SOLNN, stands for solution, and I subtract the 571.6 grams of H2SO4, that difference is going to be equal to the number of grams of water. So that's 757.4 grams of water. How does that help me? Well, I know the molar mass of water, or I can find it using the periodic table. And so if I have the mass of water, 757.4 grams of water, I can divide by the molar mass, 18.02 grams for 1 mole of water, and find that I have 42.03 moles of H2O. So notice what I have now. I have, excuse me. Notice what I have now. I have moles of H2SO4. I have moles of water, which means that I can use this to find the mole fraction. So if I add those two together, the total number of moles, actually, I'll just do this in one go. So what I have is 5.827 moles divided by the sum, 5.827 moles of the H2SO4 plus the 42.03 moles of the water. Oh, excuse me. And what that will give me is the mole fraction of sulfuric acid, which is equal to 0.122. Now notice this value is unitless. It is a fraction. It is a unitless number, basically because my moles cancel out. Next, we're asked to find the molality. And so molality is moles of solute divided by kilograms of solvent. So I already had my moles of the solute. That's the 5.827 that I found earlier for sulfuric acid. Next, I need to find the kilograms of the solvent. Again, recall that for water, I had 757.4 grams. Converting that to kilograms is easy. I divide by 1,000. So I have 7.757 for kilograms. Again, all of this is done assuming that I'm working with 1 liter. And I'm doing that because that's the information that I was given. So if I have moles of sulfuric acid and kilograms of water, that's my solvent. Then I can calculate the molality as 5.827 moles of H2SO4 divided by 0.7574 kilograms of solvent. That gives me 7.69 moles over kilograms of H2SO4, which has its own unit called the molal. And so this is written 7.69 molal H2SO4. Lastly, we're asked to calculate the molarity. Now, molarity is given by the equation moles of solute over liters of solution. I basically already have all this information. Moles of solute I found earlier to be 5.827 moles of H2SO4. And again, recall that what we're doing is we're assuming 1 liter of solution. So I have that many moles of sulfuric acid in 1 liter of sulfuric acid solution. So this is simply 5.827 moles per liter, which is also written 5.827 molar H2SO4.